Hi, my name's Isabel.
Hi, my name is Leah, and we're both programmers on Titan Robotics. But what do programmers do on our team?
Well, once Build and Electrical have finished the robot, we then write code for different parts on the robot so the robot can move. We write all of our code in Java using a library called WPIlib. A library holds the structure of the code we write. We then take this library and use it for what we want it to do, whether it be moving a motor or a piston. If you'd like to see the library that we use to write our code, we'll be leaving a link below so you can check it out.
When writing code for a robot, we use command-based programming, which is basically a way of organizing robot code. Command-based programming uses things called subsystems and commands to organize robot code in efficient ways. On our robot, a subsystem is a group of parts that comes together for one purpose. For example, our drivetrain is a subsystem, which means that all of the motors on the drivetrain are doing one thing, which in this case is moving the robot. In code, we also have subsystems, which allow us to hold all of the methods for a specific part of a robot in one place. A really nice way to think about a method is as an action that something can take. For example, when you walk from your bedroom to your living room, that's like a method that you can take. Similarly, robots also have methods, such as moving and climbing.
We use a joystick to control the drivetrain and an Xbox controller to control everything else on our robot. We begin by setting the value of a button on the controller, which we save to a variable. By using a variable, we are able to easily type in the variable for the value instead of having to type out that same line of code over and over and over again. Let's look at our climbing subsystem more in detail so we can understand how we're able to use subsystems and button bindings together.
So right now, you're looking at a robot project that I created for the purpose of this video. The first thing that I'm going to do is create a new file that will hold a new subsystem class from the WPI library. I'll call the file climber.java because it will hold the climber subsystem. Now that we've created the file and everything's looking good, we're going to declare a motor, which will be the motor that moves when the methods that we're about to write tell the robot to move. Below, a constructor has been created for us, which will run when the robot is initialized. Here, we invert the motor so it runs backwards. Next, we make a method called set with a parameter of a percentage. A parameter is a value which is passed in, kind of like a variable, which gets used in the method. Finally, we'll set the speed of the motor using the percentage we just passed in.
If we then hop over to the file robotcontainer.java, we can see where we stole all of our button and button bindings. This might seem a bit overwhelming, but right now we're only going to focus on this line. Here we see that we can make a new variable, first by specifying the variable type. In this case, we're just doing a generic variable. Next, we write in the name, which is what we'll be referencing the variable as whenever we use it. Then, we specify that this is a new type of the POV button, which stands for point of view button. This means that we're using the D-pad on our Xbox controller. Next, we say which controller we're using and the value of the button. Then, we actually say what the button is done when it's pressed. Here, we see that while this may look complicated, it's actually fairly simple when broken down. What this line means is that when the up button on the D-pad is pressed, the motor on the climber runs at half speed. However, when the up button on the D-pad is not pressed, the climber doesn't move at all. Even though it might seem like a bit much, that's all that's needed for writing a simple climber subsystem.
So now that you've seen the climber working, let's start with something a little more complicated, programming a shooter. The shooter subsystem is a little different from the climber subsystem because two motors are used instead of one. Like with the climber, we're going to create a new file for the subsystem, but this time we're going to call it shooter.java because this file is for the shooter subsystem, not the climber subsystem. At the top, like with the climber, we'll declare some motors, but this time we'll declare two motors instead of one. Finally, let's make one more method that's kind of similar to the set method in the climber called setThrottle, which sets the speeds of the shooter motors to a certain throttle using a parameter that's appropriately named throttle. Then we'll head back to robotcontainer.java where we'll be doing our button bindings. For this subsystem, we make a new button, like we did with the climber, but this one is of type trigger. Now that we've made the trigger, we'll make it so that when the trigger is pressed, it will set the motors of the shooter to a certain speed, which depends on how much the trigger is pressed. We've written all the code to make a simple shooter run, so let's deploy the code and see how it works in action.
If you have any questions about this video, or even just want to say hi, feel free to email us at frc5587@gmail.com. And don't forget to subscribe so you don't miss out on other fun educational content. Bye!